Imagine you're at the helm of an 1850s telegraph machine. Suddenly, without warning, it starts chattering wildly on its own, spitting out gibberish, sparked by an invisible force from the sun. This was the world's first introduction to the raw power of solar storms, courtesy of what we now call the Carrington event. Held as the most massive known geomagnetic storm to strike Earth, its tales are as electrifying today as the phenomena itself. Now, fast forward to our modern era. Imagine such a storm occurring today, with our deep dependence on electronic technology. The impact could be catastrophic, far beyond flickering lights or quirky telegraph machines. This scenario is not an excerpt from a science fiction novel. Rather, it's a plausible reality as Earth dances into a rhythm set by the sun's beat. Enter the upcoming solar maximum. Essentially, the sun operates on a beat known as the solar cycle or the Schwabe cycle, with cycles of dormancy and violent eruptions of solar flares and coronal mass ejections. While the concept of the solar cycle has been scientifically observed since 1755, each cycle brings its quirks and surprises. Currently, in the 25th recorded cycle, special attention is glued to its potential crescendo, the solar maximum. In the solar max, the sun displays a tempestuous nature. Sunspots litter its surface. These aren't just minor blemishes, but are regions of intense magnetic activity that can spew solar flares and coronal mass ejections into space, with sometimes Earth being in the line of fire. It's during these peaks in solar activity that Earth becomes particularly vulnerable to space weather events, drawing a parallel to the historic Carrington event. This imminent period ignites concerns, especially with the scheduled Artemis missions, marking humanity's bold return to the moon. Astronauts en route or on the lunar surface could face unprecedented levels of solar radiation, prompting both awe and a measure of fear about the implications of increased solar activity on human space exploration. However, the solar maximum phenomenon isn't straightforward. The sun's magnetic field undergoes a complete makeover every cycle. A massive polarity reversal perplexes scientists to this day. These reversals are crucial yet poorly understood elements of solar physics, impacting not only the sun's cosmic neighborhood, but also influencing conditions here on Earth. The specter of geomagnetic storms, reminiscent of the Carrington event, serves as a stark reminder of the potential technological disruptions we face. Modern society's lifelines, such as power grids and communication networks, could become its Achilles heel if a similarly massive solar storm strikes. Hence, resources are increasingly allocated toward enhancing space weather forecasting capabilities and developing robust preparedness strategies to shield critical infrastructure from celestial tantrums. Adding another layer to this cosmic interaction is Earth's own magnetic field dynamics, specifically geomagnetic reversals. These reversals, swapping north and south magnetic poles, have punctuated Earth's geologic timeline and present yet another conundrum. The last occurrence was around 780,000 years ago, and while a reversal today would likely unfold over centuries, its transitional phase could thin our protective magnetic shield, amplifying vulnerabilities to space weather. Interestingly, while solar activity has shaped Earth's climate historically, correlating with temperature changes up to the mid-20th century, this relationship has since diverged. It's a compelling shift, suggesting that although the sun is a formidable force, other anthropogenic and natural factors have assumed more prominent roles in influencing Earth's climatological narrative in recent decades. The intricate dance between celestial and terrestrial dynamics is far more than academic fascination. Understanding the sun's influence on Earth requires an elegant synthesis of astrophysics, space science, and environmental studies, making it a multidimensional challenge wrapped in magnetic enigma. As we peer into the sun's turbulent heart, we not only unravel the secrets of our celestial patron, but also fortify our preparedness for its fiery disposition. The revelations from studying such grand cosmic phenomena illuminate the interconnectedness between the sun's activity and life here on Earth. These insights help us anticipate and mitigate the impacts of future solar and geomagnetic events, a testament to human ingenuity and our relentless pursuit of knowledge. As we stand on the brink of another potential solar spectacle, our quest for understanding continues, ever driven by the power and mystery of our star. And as each puzzle piece falls into place, we're not just spectators, but active participants in this grand cosmic ballet.